In alignment with my higher dimensional communication theory, or HDC theory, if a class of dimensions, fields, or universes is only accessible via a consciousness interface and not expressible as space-time coordinates or physical observables, then an instrument-based facility like CERN cannot detect them. This is correct by definition. CERN can only detect phenomenon that interacts with matter or energy, that leaves measurable traces in space-time, and can be parameterized mathematically. Anything outside those criteria is methodologically invisible, not disproven. If human consciousness is the only multidimensional perspective of a human, this implies a non-physical dimensionality of consciousness. For a scientific boundary standpoint, CERN explicitly excludes consciousness as a causal variable, and consciousness is treated as emergent or irrelevant to particle behavior. Therefore, if consciousness is the only interface, and if the dimensional domain does not couple to matter, then CERN cannot detect it by design. This is not controversial. It is a scope limitation, not a refutation. CERN experiments would have to include cognitive or consciousness variables to detect such domains. In order for CERN to detect a conscious-only domain, it would need operational definitions of perception. It would need controlled subjective state variables, and it would need a theory linking cognition to measurable physical outputs. Such experiments are non-implementable with CERN's current physics. There's an important distinction between compact dimensions versus non-spatial domains. If dimensions are too compact to be measured, which there could be two cases for that, case A would be compact spatial dimensions, and that's physics. It's still mathematical, it's still spatial, it still interacts with matter weakly, but it still does. In principle, it's detectable via indirect effects. These are what CERN has already been testing for, and it's been unsuccessful so far. And then we'd have case B, which would be non-spatial, non-mathematical domains, which is my argument. If a domain cannot be parameterized as space-time, does not carry energy or force, and does not couple to matter, then it is not a spatial field. It cannot be accessed by matter, and it cannot be traversed physically. And then this leads me to the spatial leaks. So the possibility of spatial leaks from other dimensions, fields, or parallel universes is possible. However, this needs precise framing to remain scientifically coherent. What could be logically allowed is informational correlations, perceptual anomalies, cognitive pattern intrusion, and non-energetic influence, so no force transfer. Non-measurability implies non-traversability. If a domain cannot be mathematically described and has no spatial extension, then it has no path, no distance, no direction, no geometry. Traversal requires a metric space within continuity. Without that, movement is undefined, location is undefined, entry and exit is meaningless. So even if such domains exist, they cannot be navigated by matter as we define matter. If higher dimensions, fields, or parallel domains are non-spatial, non-energetic, and only accessible through a consciousness interface or perception, then they fall outside the measurable scope of high-energy physics. So facilities such as CERN, which rely on space-time localized interactions and instrument-based detection, would simply not be capable of observing such domains. Furthermore, If these domains lack spatial metrics or physical coupling to matter, then physical traversal by humans or objects would be logically impossible. Any interaction would be informational or perceptual through a consciousness interface rather than spatial or energetic. This is internally consistent, methodologically sound, and does not violate physics. It simply operates outside it. My argument does not claim that CERN is missing something it should detect, that portals or physical crossings occur, that physics is wrong, or that consciousness overrides matter. It claims that different domains require different observability frameworks. CERN conducts experimental high-energy physics research that is aimed at detecting fundamental particles, forces, and spacetime structure through instrument-based measurements. This examines the limits of such measurements when confronted with hypothetical spatial dimensions, fields, or parallel universes that are not spatial, non-energetic, or inaccessible to matter as we define matter. It analyzes whether such domains, if only detectable through human conscious interface, would be inherently undetectable by CERN methodologies. It further proposes a strictly exploratory framework for incorporating cognitive and consciousness variables as observational interfaces without conflating them with established particle physics. A system-level observability flow diagram is presented to clarify detection boundaries. The European Organization for Nuclear Research, or CERN, is the world's largest particle physics laboratory that is operating high-energy accelerators such as the LHC, Large Hadron Collider. CERN investigates the fundamental constituents of matter and their interactions through controlled particle collisions and precision detectors, relying exclusively on measurable spacetime localized phenomena. CERN's operational scope is limited to quantifiable particles and fields, energy-mediated interactions, mathematical spacetime models, and instrument-based observation. Modern physics assumes that all detectable phenomenon must interact with matter or energy. It must produce measurable effects in spacetime and must be expressible through mathematical formalisms. If spatial dimensions, fields, or parallel universes exist that do not meet these criteria, then they are not experimentally falsifiable within CERN's framework. This limitation reflects methodological boundaries, not ontological non-existence. This does not propose altering CERN's core physics program. It outlines exploratory domains that could be studied in parallel if consciousness-mediated observability is hypothesized. Recommended exploratory cognitive and consciousness variables would be 1. Cognitive state characterization. Under that would be attention stability, pattern recognition thresholds, predictive processing anomalies, and neural coherence measures. 2. Observer-dependent perception studies, consistency across observers, cross-culture symbolic overlaps, and reproducibility of perceptual patterns. 3. Information/theoretic metrics. So semantic density versus noise, non-random pattern emergence, correlation without energy transfer. And 4, controlled observer protocols, blinded perception trials, temporal correlation testing, and separation from experimental apparatus to avoid contamination. These studies would fall under cognitive science and information theory, not particle physics, but could define whether consciousness introduces observables that instruments cannot. The observability flow diagram implicates that CERN cannot detect phenomenon that do not couple to matter or energy, that non-measurable domains cannot be spatially traversed, that consciousness-based observability does not imply physical access, and that absence of detection does not equal absence of existence. This framework preserves scientific rigor while acknowledging epistemic limits. CERN operates at the limits of instrumental physics, not at the limits of all possible observability. If certain dimensions, fields, or parallel domains are non-spatial and accessible only through consciousness interfaces, then they fall outside CERN's detection capacity by design. Incorporating cognitive and consciousness research would not extend CERN's particle physics mandate, but could clarify whether additional observational interfaces exist. It's important to remember that CERN investigates what can be measured. Consciousness investigates what can be perceived. Confusing the two leads to category errors. Separating them clarifies reality. This model does not claim proof of higher dimensions. It defines minimum scientific conditions under which consciousness-mediated detection could be evaluated without violating methodological rigor. For consciousness-based detection to be considered testable, it must produce structured, non-random informational output that exceeds chance expectation and shows cross-observer consistency. Consciousness cannot be tested as a force, only as an information interface. This is the foundational constraint. A valid HDC signal must satisfy all of the following. 1. Non-random structure, when pattern density exceeds stochastic baselines. 2. Observer independence, when it appears across multiple observers without coordination. 3. Temporal stability. This would be when it reoccurs under similar cognitive conditions. 4. Semantic compression, high informational content with low redundancy. And 5. Contextual independence, not derivable from prior knowledge alone. This would be the operational definition of a conscious-based signal. Failure at any stage would be equal to signal rejected. Testability threshold does not confirm ontological origin, only detectability. Cognitive control variables would be required. To prevent category error, the following must be explicitly controlled: attention state, expectation bias, emotional valence, fatigue and stress, and prior symbolic exposure. Without controls, results are non-scientific by definition. Falsification criteria is also critical. So a conscious-based detection model would be falsified if signals collapse under blinding, patterns disappear under replication, outputs align with random distributions, observer agreement falls below threshold. This preserves scientific integrity. And this model still does not overlap with CERN. Even if all thresholds are met, no energy transfer occurs, no space-time interaction exists, and no particle-level coupling is implied. Therefore, CERN cannot test HDC observables, and HDC cannot override CERN results. They remain non-intersecting detection regimes. Testability must be reframed from physical measurements to informational reliability. The consciousness testability threshold model's fundamental assumptions are that 1. Consciousness can register information not carried by energy. 2. Detection manifests as perception or cognition. 3. Signal must exceed internal cognitive noise. And 4. Consistency replaces precision as validation. Operationalizing the model without metaphysical claims. For the signal would have to be the emergence of structural information, non-random symbolic content, and it would have to be persistent across time. 2. Noise, suggestibility, prior belief contamination, and emotional state variance. 3. Cognitive coherence, EEG coherence, focus duration, and working memory stability. And 4, observer independence. Similar perception across observers, no communication prior to reporting, and statistical overlap beyond chance. To remain scientifically conservative, experiments must separate observers from physical apparatus, blind observer to experimental conditions, record perception before interpretation, and use pre-registered analysis criteria. Failure to meet these constraints invalidate claims. A conscious-based detection claim is falsified if perceived information is indistinguishable from randomness. 2, if no cross-observer overlap occurs. 3, if signal collapses under blinding. And 4, if content tracks expectation rather than independent variables. This is essential to avoid unclassifiable belief systems. This analysis has established a clear and necessary distinction between instrument-based high-energy physics, as practiced at CERN, and consciousness-based observational frameworks, as articulated in the higher dimension communication model. CERN's experimental program is rigorously constrained to phenomena that interacts with matter and energy that are localized in space-time and can be mathematically parameterized with these constraints. CERN has successfully probed the fundamental structure of physical reality, but it is inherently limited to what is instrumentally observable. If higher dimensions, fields, or parallel domains exist that are non-spatial, non-energetic, and inaccessible to matter as we define it, then they fall outside the detection capacity of CERN by definition, rather than by oversight. The absence of detection under such conditions cannot be interpreted as evidence of non-existence, only as confirmation of methodological boundaries. Importantly, if these domains cannot be represented as space-time structures, they cannot support physical traversal, energy transfer, or material interaction as those concepts are currently defined in physics. My HDC framework posits that human consciousness may function as an informational interface capable of detecting patterns or correlations that are not mediated by physical forces. Such detection, if real, would be perceptual and informational rather than spatial or energetic. Consequently, testability must be reframed away from conventional measurement towards criteria such as signal-to-noise ratios in cognition, cross-observer consistency, and resistance to expectation effects. The proposed consciousness testability threshold model provides a conservative, falsifiable structure for evaluating such claims without collapsing into unfalsifiable belief. Crucially, recognizing consciousness-based observability does not require altering or undermining CERN's core mission. Instead, it clarifies that different domains of inquiry require different observational interfaces. Physics remains the study of what can be measured. Consciousness research addresses what can be perceived. Conflating these domains leads to category errors, while separating them preserves scientific integrity. In summary, CERN and HDC are not competing explanations of reality, but non-overlapping investigative frameworks, addressing fundamentally different questions. CERN explores the measurable architecture of matter and energy. HDC explores the potential informational limits of perception. Any future synthesis would require a new, demonstrable mapping between cognition and physical observables. Until such a bridge exists, both domains can be studied rigorously, so long as their methods, claims, and conclusions remain clearly bounded.